Hello guys, so in today's video we're gonna do impossible extremal principle IMO questions with ease because we're using a lot of logic. Okay, we're providing easy solutions, so let's think different. Okay, so let's start in. First question: at a party, every person shakes hand with at least one other person. Prove that there exists two people who shook hands the same number of times. Okay, first of all, let's take let's say that there's only two people in the party, okay? So they shook hands with each other, one, uh, and, I mean, here one and there one. So the numbers are equal. Even if we want to take a larger sequence, let's say three people, uh, two people should have at least one, and one person should have shook hands with both the person, right? Or else the sequence would not be true. It must be, the combination must be true. So one person shook two hands. One person shook hands with two people, and two people shook hands with each other. Like, not each other, but one other person. Okay? So that's it. Yes, there exists. Proved. So coins are placed on some squares of an 8 into 8 chessboard so that every row and every column contains at least one coin. Prove that one can remove coin so that each row and column contains exactly one coin. Okay, so let's say we have only one coin in all the rows and all the columns except for one single row. Sorry. Uh, for one single row alone, you have two coins. If you take out the one coin, you have only one coin in all the rows and the columns, right? So that's just pretty simple. This is taking some examples. Extremal principle is extremely easy. You just take the maximum, take the minimum, take some examples. That's it. So a finite set of positive integers has the property, okay, for any a and b belongs to S, the value modulus of a minus b is also in S unless 0. To prove that S consists exactly of the positive multiples of some integer d. Okay, that's true, right? Because let's say you take 1, all of them must be a multiple of 1, right? Just take an example. 1 is the minimum, 1 is the bare minimum. So you take the minimum one. So for one, everything must be right because all are integers. So all are the multiples of one. So from 101 distinct positive integers chosen from 1, 2 up to 200, prove that there exist two numbers such that one divides the other. Okay, that must be true because if you take uh, 1, okay, let's say you take 1 and you take 2 and you take 4 and so on, okay? 4 is completely divisible by 2, and 2 is completely divisible by 1, and 4 is completely divisible by 1. So there exists at least two numbers. Let's say you only, okay, so you only take like this. Prove that there exist two numbers. Just take an example, minimum example, 1 and 2. And 2 is completely divisible by 1, so there exists, right? So finite set of points lies in the same plane, not all collinear. Every pair determines a line. Prove that there exists a line passing through exactly two of the points. Okay, now this is definitely true, right? You take any 2 points, definitely a line must be passing through them. Like anywhere in the graph, you can plot them, and the angle of the line changes and the point of contact changes. But otherwise, a line can definitely do that. So in a tournament, every player plays once, no draws. Prove that there exists a player such that every other person either lost to that player or lost to someone who has lost to that player. Okay, first of all, let's say only two players. The guy who played with the player who won had lost with him and lost every match. And now let's take a larger one. Three players, okay? So the third rank will be 0, 1, and the second rank will be 1, 1, and the first rank would be all one. So the second rank had lost to the first rank, but still won against the third rank. So third rank lost to someone who had lost to the first player, and also he lost to the first player. So that's the key idea. So given a finite sequence of positive integers in one, we'll choose two numbers a and b and replace them with models of a minus b. Okay, this sort of thing, they can't be positive. I mean, they can't be the same numbers. That's okay. Prove the process eventually terminates. No move for me. Okay, let's say you have n positive integers. Okay, so you keep on eliminating numbers, right? Because if we replace a and b with a minus b, then one number is reduced. Like that, if you keep on repeating, only one number will remain, which means there's no moves left to do. You can't do any move with just one number. If you write the same number again, it will be discarded because of zero. Prove that every finite graph contains at least two positive vertices with equal degree. That's true, right? You take a line, if it doesn't keep on extending until infinite, it ends at 2 points, okay? This point is one vertex and this point is the second vertex, okay? So you have two vertices, like the corner, the end point of the line, okay? Or you take let's say a parabola, okay? But it ends, okay, let's say hypothetical situation, please. So it just ends at a point. So it has two ending points, right? So that's the key idea. Several cards are drawn in a circle with no three cards passing through a single interior point. Prove there exists a card that intersects at most at two other cards. Okay, first of all, let's just take three cards. One is diameter, the other one is the second diameter with a different angle. I guess you can understand it. And then the third one is a small card which passes through, I mean, which cuts the second diameter, which is the angled diameter. So we can clearly see that the angled diameter cuts both the small card and the first diameter, which is not much angled and pretty horizontal, let's say. So last question. The integers 1, 2, up to 200, I mean, up to 100 are each colored red or blue. Prove that there exist two numbers of the same color whose difference is divisible by 99. Okay, let's say one is red and 100 is red, or at least one is blue and 100 is blue. Let's just say they have the same color, right? So 100 minus 1 is 99. 99 divided by 99 is 1. It's completely divisible. That's as simple as that, right? So it's not at all complex. It just twists the question. That's all about IMO. So that's it for today, guys. Bye. See you tomorrow. I've also shared a link on my Python playlist and my AP playlist on my club from Monday. If you want to get into top US universities. Oops. Just a minute, guys. Oops, okay, sorry. So from Monday, it will be pretty much structured. Right now, I'm just uploading some tricky questions and just some normal stuff. From Monday onwards, we're gonna go so structured so that we can mutually help each other to get into the top universities, right? So that's it for today, guys. Bye. See you tomorrow.